A stunt car in a movie is set to drive off of a cliff and explode when it hits the ground 60 meters below. The car is moving at 30 meters per second as it drives off of the cliff. The director needs to line up his shot of the explosion, so he needs to know where the car is going to land. How far from the base of the cliff will the car land and explode? We have our picture drawn up here on the board. Here's my car. It's traveling horizontally with a speed of 30 meters per second. We know it's 60 meters below to where it's going to crash. How far away that is what we're trying to find. And as always, all projectiles have an acceleration down negative 9.8 meters per second squared. We're going to pull our numbers from the problem and from the picture and put them into our two columns, our left and right stuff and our up and down stuff. All the left and right numbers are going to be in black. All the up and down numbers are going to be in green. We know the car is traveling 30 meters per second. That's to the right. So that's in my X column. And we're trying to figure out how far away it's going to land. So that puts my question mark in displacement in the X. In the Y column, we know we're going to drop 60 meters. So negative 60 meters for my displacement. We're driving horizontally off the cliff, so my initial velocity in the y direction is 0. I don't know final velocity. The acceleration is negative 9.8 meters per second squared. We can't solve for d in the x direction right away because we would need to get time. So we're going to solve for time in the y direction and then use it to get the thing we really want, which is displacement in the x direction. We're going to pick the equation that does not have final velocity in it because that's the thing we don't have and don't care about. So d equals v naught t plus 1/2 a t squared. Because v naught is 0, this term just goes away, leaving us with d equals 1/2 a t squared. Rearranging this for time, I'm going to multiply by 2 to get rid of the half. So on the left side, I now have 2d. I'm going to divide my a over. So now that's in the denominator. And that's going to leave t squared on the right. But I don't want t squared. I just want t. So to get rid of a squared, I do a square root. We're now ready to plug our numbers in and solve. 2 times negative 60 divided by negative 9.8. Put that underneath the square root symbol, and that's going to give us a time of 3.5 seconds till the car hits the ground. So in the x direction, I now know how long I have to travel, which is 3.5 seconds, and now I just have to solve for displacement. Again, left and right motion in projectile motion is constant velocity motion. So we're going to use our constant velocity equation, d equals v times t. No algebra to do because we're just solving for displacement. So that's 30 meters per second times 3.5 seconds. Plug that into my calculator, and I find out that the car is going to land 105 meters away from the edge of the cliff.